Welcome back to Cosmic Compass. Today, let's embark on a journey to explore one of the greatest paradoxes of our existence, the Sun. It is our life giver, the star, that powers every breath we take and every meal we eat. But hidden within its brilliance is a destructive force, one capable of reshaping life on Earth in ways few of us truly imagine. We'll uncover how the Sun fuels life, how it sometimes lashes out in violent solar storms, and what history has already shown us about the devastating power of these cosmic tempests. And then let's ask the uncomfortable question: what would happen if the largest solar storm ever recorded struck our world today? What if tomorrow the Sun released a storm so powerful that it could wipe out our electricity grids, shut down satellites, and plunge much of the world into chaos? It may sound like the premise of a science fiction movie, but it's a real possibility, one written into the history of our planet. The Sun is far more than the glowing ball we see in the sky each day. It is a colossal engine of nuclear energy, hurling billions of tons of electrically charged plasma into space. These eruptions, known as Coronal Mass Ejections or CMEs, travel in all directions. When they strike Earth, we call them solar storms. These storms are breathtaking in both scale and speed. The plasma racing outward can travel at over 1 million kilometers per hour. At that velocity, one might imagine humanity ducking for cover whenever such material is hurled in our direction, and yet we survive day after day. Why? Because Earth is protected by natural defenses that shield us from most of the Sun's fury. Let's step back and examine what drives this extraordinary activity. Our Sun is considered relatively stable for a star. It belongs to a class called yellow dwarfs, and for over 4 billion years it has produced energy at a nearly constant rate. Compared with many stars in the galaxy, that stability is a gift. But stability does not mean calm. If we observe the Sun's surface through instruments like NASA's Solar Dynamics Observatory, we find a boiling, turbulent landscape. Sunspots, flares, and giant loops of plasma are visible every single day. The Sun itself is not solid liquid or even gas. It is plasma, a soup of charged particles, ions, atoms, and electrons churning under immense heat and pressure. At its core, hydrogen atoms are fused into helium through nuclear fusion, releasing enormous amounts of energy. That energy moves outward slowly, so slowly that a single photon may take over 100,000 years to journey from the Sun's core to its surface. Once closer to the surface, convection takes over, hot material rises, cooler material sinks, and the star glows like a vast furnace. Plasma, being an excellent conductor of electricity, interacts strongly with magnetic fields. Beneath the Sun's surface, magnetic fields twist and tangle. When they rise to the surface, they create sunspots, often appearing in pairs with opposite polarities. Around these regions, magnetic loops stretch high above the surface. Sometimes the stress in those fields grows too great. Imagine twisting a rubber band until it snaps. In the Sun's case, when magnetic lines of force break and reconnect, the energy unleashed equals millions of nuclear explosions at once. This is what we call magnetic reconnection, the trigger for solar flares and coronal mass ejections. When a CME forms, vast bubbles of plasma are launched outward at speeds reaching thousands of kilometers per second. Millions of tons of solar material are ejected, setting off on a journey through the solar system. These ejections do not discriminate. Every planet in the solar system feels their impact. Take Venus, for example. Lacking a strong magnetic field, its upper atmosphere is continually stripped by the solar wind and by CMEs. Over time, this process has left the planet shrouded in a toxic haze of heavy molecules, a hostile world where life, as far as we know, cannot thrive. Earth, by contrast, is fortunate. Our magnetic field deflects the majority of charged particles, diverting them around the planet and funneling some towards the poles. When they collide with our upper atmosphere, the result is one of nature's most spectacular displays, the aurora. Thanks to our magnetic shield and thick atmosphere, we are largely safe. But are we entirely protected? That's the real question. To understand the danger we need only turn to history. The year was 1859. On August 28th, observers noted unusual auroras visible even as far north as Queensland, Australia. A few days later, on September 1st, astronomers Richard Carrington and Richard Hodgson independently witnessed something extraordinary, a sudden, dazzling solar flare. Within 18 hours, Earth was struck by one of the largest solar storms ever recorded. Normally, CMEs take several days to cross the 150 million kilometres to Earth. This one arrived in less than a day, its speed boosted by a previous ejection that cleared the way like a cosmic slipstream. The results were unprecedented. Auroras blazed across the skies, visible not just in polar regions but near the equator. In the Caribbean, Mexico, Cuba, even Colombia people looked up to see skies illuminated in shimmering green and red. In the United States, the light was so bright in the Rocky Mountains that miners awoke in the middle of the night believing it was dawn and began making breakfast. But beauty came with danger. Telegraph systems across Europe and North America failed. Operators received electric shocks from their equipment, and pylons sparked from the charged atmosphere. In some cases, messages were transmitted even after power supplies had been disconnected, the wires themselves charged by the storm. For 19th century society, still in the infancy of electrical technology, the damage was startling but manageable. For us today, the same event would be catastrophic. The Carrington Event stands as the benchmark, but it has not been the only storm. In March 1989, a CME struck Earth, disabling satellites, disrupting radio signals and shutting down the power grid in Quebec, Canada. In just 90 seconds, the grid collapsed, leaving millions without electricity for 9 hours. Though disruptive, that storm caused only temporary damage, but it serves as a warning. Technology today is more advanced and more fragile than it was even 3 decades ago. Let's imagine for a moment that a CME of Carrington magnitude struck Earth in our modern era. What would happen? The immediate effect would be a geomagnetic storm compressing Earth's magnetic field. Our satellites would be the first casualties. GPS weather satellites, communication relays, all would be at risk of failure. On the ground, long power lines and transformers would experience surges strong enough to destroy them. Unlike telegraph lines of the 1800s, modern electrical grids span continents. The vulnerability is immense. If major transformers were destroyed, replacing them would not be easy. They are custom-built, expensive, and take years to manufacture. In the meantime, millions could be left without power, not for hours, but for months or even years. Think of what that means for daily life. Without power, refrigerators fail, food spoils, and supply chains collapse as fuel pumps and transport systems shut down. Payment systems no longer work. Hospitals rely on generators, but even those run out of fuel. Communications fail, leaving populations cut off from their governments and from each other. The cost to the United States alone has been estimated at $2.6 trillion, with recovery times stretching from 4 to 10 years. Social consequences could be even worse. Unrest, looting, and survival instincts taking over as trust in institutions fades. Some studies suggest that 2/3 of the US population could perish in such a prolonged disaster from hunger, disease, or societal breakdown. When framed this way, the threat is clear. A Carrington-scale storm today would not just inconvenience us, it could unravel the very fabric of modern civilization. And here's where the story becomes even more unsettling. In 2012, a CME larger than the Carrington Event erupted from the sun. It was observed by NASA's Stereo spacecraft, which recorded distortions as the storm swept past. Earth narrowly escaped by pure chance. Had the planet been in a slightly different position in its orbit, we would be telling a very different story today. Can we protect ourselves? To some degree, yes. Since 1995, NASA has monitored the Sun with space telescopes capable of detecting CMEs, Because light travels faster than ejected plasma, we can receive roughly 17 hours of warning before impact. This advance warning forms the basis of what is called the solar shield program. In theory, it allows power stations to be shut down in time, shielding them from the worst surges. Temporary transformers are being designed and proposals exist to upgrade electrical grids worldwide. But here's the reality: progress is slow. Responsibility is scattered across agencies and funding is limited. The Department of Defense points to Homeland Security. Homeland Security points to the Department of Energy. And while bureaucracies debate, our vulnerability remains. Most of the world's population has never even heard of CMEs. People fear asteroid impacts or alien invasions, but the more likely disaster, a super solar storm, rarely enters public discussion. So where does that leave us? The sun is both our life giver and our potential undoing. Every bite of food we eat, every breath of air we take, owes itself to its steady light. Yet in the blink of a cosmic eye, that same star could unleash a storm capable of erasing decades of human progress. We cannot predict when the next great CME will occur. It might happen tomorrow or not for thousands of years, but we know it will happen again. The question is, will we be ready, or will we wait until catastrophe strikes before we act? As we've seen, the sun is both a guardian and a threat, steady and nurturing, yet capable of unleashing storms that could cripple our modern civilization. We cannot control it, but we can prepare for it if we choose to act. The question remains, will humanity rise to the challenge before disaster strikes, or will we leave our fate to chance? If you found this journey through the power and peril of our star enlightening, consider joining us again here on Cosmic Compass. Together, let's keep exploring the wonders and the dangers of the cosmos.